I would like to share with you the results of two projects in a research program on upgrading the Philippine national standard for virgin coconut oil, as well as the Philippine VCO industry. Project 1 is entitled Physico-chemical factors which affect the quality of VCO. This is the status of the Philippine VCO industry. As you can see, 75% of Philippine VCO processors are micro and small-scale enterprises with a capitalization of less than 15 million pesos. These MSMEs need the most assistance in terms of technical requirements in order to maintain the quality of VCO. This is export performance of Philippine VCO from 2006 projected to 2020. As you can see, the exports peaked in 2015 and slowly declined afterwards. This may be due to increased competition globally, which points to the need to improve the quality of Philippine VCO. Virgin coconut oil is the oil obtained from the fresh, mature kernel of the coconut by mechanical or natural means, with or without the use of heat, without undergoing chemical refining, bleaching, or deodorizing. This is RBD coconut oil, and which does not lead to the alteration of the nature of the oil. There are three methods of making VCO. The first is the Expeller method, the second is a fermentation method, and the third is a centrifuge method. However, regardless of the method, the quality of the VCO should be the same, and it should meet the standards for VCO. In 2007, the Philippine National Standard for VCO was adopted. Table 1 gives the GC profile of fatty acid composition of VCO. However, this table was obtained mainly from Codex Alimentarius, which is the international coconut products which are obtained, sent to Rotterdam. Therefore, this is not specific to Philippine VCO. Table 2 gives a table of properties of VCO, such as the moisture content, free fatty acids, peroxide value. However, this is not sufficient to ensure the quality of VCO. So there's a need to upgrade the Philippine National Standard to improve VCO quality, as well as to prevent adulteration, in particular, adulteration of VCO with RBD coconut oil. So the objective is to upgrade the Philippine VCO industry as well in order to meet these new standards. These are the results of this study. This is the fatty acid composition by GC. If you compare the fatty acid range from the 2007 PNS and this work, you can see that this work was obtained from Philippine VCO. So we are sure that the VCO coming from the Philippines will meet the fatty acid profile. We were able to develop a simple method for detection of adulteration of VCO, in particular by RBD coconut oil. So at 2078 nanometers, VCO absorbs below 1.5 absorbance units, while non-VCO samples, including RBD coconut oil and white coconut oil, absorb at around 3 absorbance units. Therefore, the maximum absorbance value for VCO is set at 278 nanometers and should be less than 1.5. Another important result of this study was to understand the effects of various parameters in VCO quality, such as moisture, the effect of microorganisms, as well as high heat. The effect moisture increases the free fatty acids in VCO, which leads to rancidity. Presence of microorganisms gives the acid flavor due to acetic acid, and high heat may lead to the yellowing of the VCO due to the reaction of proteins with carbohydrates during the processing. So as a result of this study, we're able to, we're in the final stages of drafting the new Philippine National Standard for VCO for human consumption, as well as VCO for cosmetic use. I'd like to acknowledge again and thank PCIEERD DOST for funding this project. the Philippine Coconut Authority and the Virgin Coconut Oil Philippines Association for the coordination, and the VCO cooperators who participated in the study. So on that note, we thank you, and we hope that the quality of VCO continues to improve. Thank you.